Hey there, mathletes. Here we are looking at section 6.1. We will be using properties of perpendicular bisectors and angle bisectors to find measures and distances. So, first thing we want to talk about is our theorems. Our perpendicular bisector theorem. It states that if we have a point that is on the perpendicular bisector, so if C is on that, okay, then we can assure that our distance from C to A is equal to the distance of C to B. Okay. The converse of that's also going to say is that if on a plane, if a point is equal distance from the endpoints of a segment, so if D is equal distance from points A and B, then we know that it's going to fall on that perpendicular bisector. Okay, so I want to kind of use our GeoGebra here to kind of investigate this so we can see that we have a line segment AB. So if we go ahead and we do a perpendicular bisector, so I can select points A and point B, and I get a perpendicular bisector. Then if I want to create a point on that perpendicular bisector, then I can show that the distance from A to C is the same distance of B to C. So notice it's a dynamic kind of software program. So what's nice is I can move things around and I can say, hey, no matter where we are at on that perpendicular bisector, we can see that this distance AC is equal to BC. Okay. So is there enough information in this diagram to conclude that this point N lies on the perpendicular bisector? Okay. So because we know that we don't know that Kn is equal to Nm. If we knew that they were equal, then we could say that NL lies on that. Okay, so there's not enough information. Okay, so not enough information to conclude that it lies on that perpendicular bisector. Okay, so in this diagram, given that Zx is perpendicular to YW or WY, okay, and YZ is 13.75, I can also conclude that WZ is equal to 13.75 as well. Okay? These are congruent when we know that this is our perpendicular bisector XZ or ZX. Okay, so if ZX is the perpendicular bisector of WY, okay, WZ, this segment, and YZ are congruent. So if I want to find YZ, I can solve this equation for N. So because they're congruent, I can say that 4N minus 13 equals N plus 17. Get all my N's on one side, so I'm going to subtract N. Make sure to try and line up my equal signs, so I get 3N minus 13 equals 17. I'll get my constants on the right side, so I'm going to add 13. Add 13. I get 3N is equal to 30. Divide by 3. Divide by 3. So I get N is equal to 10. Now that I know what N is equal to, I can plug that in to find YZ. So YZ is using this expression here. So I can substitute in N. I get 10 plus 17 equals YZ. So 27 is equal to YZ. Next example. So using this diagram and the given information to find the indicated measure. So I want to find Wx. So I want to find this length here. Okay. When Wz is 20.5 and Wy is 14.8 and Yz is 20.5. Okay, so now that I know that Yz and Zy are equal, then I know that Zx is the perpendicular bisector. And since it bisects the segment Wy, okay, Wy is equal to 14.8. Okay, so if I take 14.8, because it bisects it, we cut it in half, we get 7.4. That is equal to our two equal parts, Wx and Xy. Okay, we were just asked to find Wx. Okay. So our other theorems deal with our angle bisectors. So angle bisectors theorem says if a point lies on the bisector of an angle, then it is equal distance from the two sides. But just remember, when we're talking about a point on a line and we want to talk about distances, a point to a line, that distance has to be perpendicular. Okay, we don't talk about distance of a point to a line other than it just being that perpendicular distance. Yes, there's all these other distances that kind of go off this way, but to be consistent, we always talk about the distance from a point to a line is it's on this perpendicular route, which will always be the shortest distance to a line and a point. Okay. Converse of this states that if a point is in the interior of an angle and it's equal distance from the two sides of the angle, then it lies on the bisector of the angle. So if it's equal distance, okay, and again, that distance has to include our knowing that that distance is perpendicular. There, okay. So we can go ahead and look again at a kind of dynamic way of looking at this. So if we look here, I have my angle, okay, BAC, and if I want to go ahead and do a angle bisector, you can look at the bisector of BAC, okay, and I can identify some point on that perpendicular, or that angle bisector. And from that point, what I'm going to do is I'm going to make a perpendicular line. So perpendicular from that point to that line, perpendicular from that point to that line. Okay. So now we have these intersections. So that point's the intersection, and that point's the intersection. Okay. Actually, I didn't get that intersection there. So that intersection's right there. Okay. And it's there. Okay. So if I go ahead and look and I measure the length of E to D and EF to D, okay, and as I drag this point and move B, I can see that that distance is always going to be the same. Okay. I can extend that out and move it in. Okay. So, how are we going to use this? Do we have enough information to conclude that QS bisects angle PQR? Okay, so if we look here, we see that they're equal distances here. But what we don't know, so our red flag, is that we don't know these angles here. These angles, without knowing that angle QPS is equal to 90 degrees and angle QRS equals 90 degrees? We don't know those. Okay, so there's not enough information. Okay, to conclude that QS bisects that angle. Okay. So use a diagram. BD bisects angle ABC. Okay, so if I know that DC, then I know that DC is going to be congruent to DA. Well, DC equals 6.9, so that also equals DA. Okay, example 6. So using our diagram here, we're going to BD bisects angle ABC. AD is, so that segment, AD and DC are going to be congruent. I know that AD is 3Z plus 7. And I know that CD is 2Z plus 11. So to find CD, I need to solve for Z. So we set up an equation to solve for Z. So 2Z plus 11 equals 3Z plus 7. Get all my Z's on one side. So I get Z plus 7 equals 11. Get all my constants on the other side. So I'm going to move 7 over to the other side by subtraction property of equality. So I get 4 is equal to Z. So now I can substitute that in up here, combining those. So I get 2 times 4 plus 11 equals CD. This is 8 plus 11 equals 19, which is equal to CD. Okay, another example here. So find the measure of angle ABC when AD equals 3.2. So AD equals 3.2. And CD equals 3.2, and that's the perpendicular distance. So therefore, I know that BC is the angle bisector. So I'm still figuring out my stylus. Is the angle bisector. Right. So then we can conclude that since the angle bisector, we know that the measure of angle DBC, so DBC there, is equal to 39 degrees. So then we also know that's equal to the measure of angle DBA. And we want to find angle ABC, so using our angle addition property, we know that the measure of angle ABC equals the measure of angle DBC plus the measure of angle DBA. Well, both those are 39 degrees. So the measure of angle ABC is going to be equal to 78 degrees. Okay. Final example here is we want to write an equation of the perpendicular bisector of the segment with endpoints -1, -5, and 3, -1. So first thing I'm going to do is I'm going to just identify, I'm going to use 3 different equations that are important. I'm going to need to know my slope-intercept form of a line, because that's going to be my equation that I write as a perpendicular bisector, because this is a line, right? So from that, I'm going to need my midpoint formula, because my midpoint will be the bisector, and I need to know my slope formula, because I know that it needs to be perpendicular, and slopes that are perpendicular are opposite reciprocal. So I'm going to need to use all three of these formulas here. So the first thing I'm going to do is I'm going to find the slope of this line. So let's go ahead and call this x1, y1 for that point here. That's point 1. Point 2 is x2, y2. That's point 2 there. So to find my slope, I'm going to use this equation. I'm going to say that slope of this line is equal to y2, so -1 minus -5 over x2, which is 3 minus -1. So here I'm going to get -1 plus 5, and that's 4, over 3 plus 1 is 4. 4 over 4 is equal to 1. And that makes sense for my graph because I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So I got a slope of 1. So a slope that is perpendicular to that slope is opposite reciprocal. So that's the new slope, we'll call it M2, has to be the opposite. So I change the sign and I flip it. Well, when I flip 1 over 1, I still get 1 over 1, or just -1 will be my slope. So now using my equation of a line, I have this so far. I have y equals -1 x plus my b. Well, I don't know my b value. So in order to do the b value, I need to know an x and a y value that's going to lie on my line that is the perpendicular bisector. Well, that point I'm going to get because the midpoint has to be on my perpendicular bisector because it bisects that segment. So let's go ahead and find the midpoint of that. So I'm going to use -1 plus 3 divided by 2 over y1, -5, plus -1 divided by 2. This will end up being 1, -3. If I plot that on my graph, sure enough, that seems like a reasonable place for that to be the midpoint. Okay. So now I'm going to take those and plug it into my equation to solve for b. So this is my x value, and this is my y value. So as I use my slope from before, I'm going to have my y, -3, equals -1. My x is 1 plus b. So I get -3 equals -1 plus b. Isolate b, so I'm going to add 1 to both sides. And I get -2 equals b. So now that I have that, I insert it into this equation here, and I get my final equation out. So I get y equals, my slope is -1 x, and my b value is -2, which is my y-intercept. So if I think about graphing this line, I'll graph it in purple here. So this line, y-intercept's -2, so I'm here. Slope's -1, so I'm coming down here, coming down here, coming down here, coming down here, coming down here. So then I can see that this line is my perpendicular bisector. Okay, that concludes our notes for today. Please highlight any questions and bring them to office hours if you have them.